Alright, situation 21 tayo. November 2021 para dito. Ito yung problem. So, the computed wind load acting on the joints of the hull truss shown are as follows. Meron kang P1, P1, P2, P1 and P4 are equal. P2 and P3 are equal. And you have dimensions S and H. So, tanong dito, the total reaction at G, support G, the force on member, force on member CH, ito, force on member CH, and the force on member DJ. Lagyan muna natin ng values. Okay, by the way, these are wind loads. So, the wind loads are always acting perpendicular to the roof. Perpendicular yan, yung assumption natin. Yan talaga yung analysis. Okay, kunan muna natin yung free body diagram for the whole structure. Tanggalin natin yung ating support. So, this is pin support. Ito naman is a roller support. So, ito yung ating free body diagram. Dalawa sa pin support, horizontal and vertical. So, yung total reaction dyan is by using Pythagorean theorem. Dito naman sa G, since yung ating support is roller, automatic, yan na yung ating total reaction, R sub G. So, determine the total reaction at G, kilonewtons. Kunin na lang natin yung mga prerequisite values para later. Ito, theta, kailangan natin yan. Tawagin ko itong Y1, itong vertical member. Ito naman, Y2. Ito rin, kailangan natin yung values dyan. These are equal by symmetry. Let's say X, kasi 1.8 yung ating span. So, equal lang yan. Kukunin natin yung mga values dyan. Madaling kunin sa theta by just using this triangle. We have arctangent, opposite 2.7, adjacent tatlong 1.8. So, you have 26.565 degrees. Yung Y1, pwede by ratio proportion. You have 2.7 is to tatlong 2.8 equal to Y1 over 1.8. Or basically, that is 1/3 of 2.7 kasi symmetry yan. And that is 0.9 meters. For Y2, yung Y2 naman, that Y2 is just equal to 2/3. 2/3 naman siya by symmetry. 2/3 of 2.7. Again, you can do ratio and proportion. Ganyan. Nakuha natin si Y2. Now, after natin makuha yung Y2, yung X naman, kunin natin. Ito na lang, consider na lang natin itong maliit na triangle. So, by Pythagorean theorem, X is the hypotenuse. Square root of 1.8 squared plus Y sub 1 squared. Y sub 1 known, kuha natin siya. 2.012 meters. Okay? So, paano kunin si R sub G? Moment sa A, pinakamadali. Moment sa A. To eliminate this other unknown. Summation of moment at A, let's say positive clockwise. Okay, itong forces dito, walang moment na maidudulot dito sa point A. So, eliminated sila. Una, 17, moment arm is X kasi perpendicular yan. Diretso na. Huwag mo na siyang i-resolve to components. 17 times X. The next force is 17. By the way, clockwise yung moment caused by these four loadings. 17, then dalawang X. Plus 17, dalawang X. 8.5, tatlong X. 8.5, tatlong X. Yung RG natin will cause counterclockwise about A. So, R sub G, then 6 na 1.8. 6 na 1.8 equal to 0. Kuha natin si R sub G. Lalagyan natin ng values yung X. Okay, sinimplify lang natin. Yung R sub G will be 14.252. That's 14.26. 14.26. Siguro sa rounding up yan. Okay? Next. Force on member CH. So, nilagay ko lang yung mga values dito na nakuha natin kanina. Force on member CH. Pinakamadaling way dito to solve for this force member, mahirap yung gawin method of joints. Kasi kahit it's either dito sa point C or point H tayo. So marami yung unknown. Pinakamaganda method of section. I-cut ko siya in this manner. So tatlo yung forces involved. Yan. Cut ko siya ganito. Eliminate natin. Basta kinat mo na yan dito, titingnan mo lang lahat on that section, on the left section. Disregard the other forces na hindi na include sa cut. Disregard talaga, diretso. So ito yung ating forces. Ito yung gusto natin makuha, force on member CH. Meron ding forces dito, which is HI and PC. But pwede natin yung eliminate sa solution by just taking moment at A. Summation of moment at A tayo. So, itong force na yan is directly towards A and yung point C directly towards point A. So, kung nag-moment na dito, yung unknown mo lang is CCH. By the way, yung style ko dito, I always assume positive or tension. Ina-assume ko parati pag nagkatayo tension para hindi na siya nakakalito. Kung mag-negative man yung output natin, that means it is in compression. Okay? So, kailangan natin ng angle ng CH. Take note, if this is 0.9, yung ating vertical member, 0.1, 0.8, and 1.8. If this is theta, then the inclination of this member is also equal to theta with the horizontal. Okay? Nakuha natin yung theta kanina. So, pwede na tayo mag-moment at A. Now, ito pa yung isang technique dito para hindi masyado complicated yung solution natin. You have here the force CH. Mag-decide ka kung saan mo i-orient yung kanyang components. Ito yung components vertical and horizontal. Na kung dito ko siya i-orient, wala namang problema. Makukuha pa rin natin yung correct answer. But, yung ating vertical component will cause moment at A and also the horizontal component will cause moment at A. So, medyo mahaba yung solution natin. Imagine mo lang, take note that the forces can be applied anywhere sa line of action, sa straight line. Pwede natin tong transfer dito sa point C, yung ating components. Pwede natin dyan i-orient. Okay? So that, ito yung ating X component, ito naman yung Y component or vertical component. Notice, summation of moment at A tayo, si positive clockwise. So, yung yung horizontal component ni CH, hindi na siya magdudulot ng moment kay A kasi direct to the point of moment yan. Yung magdudulot ng moment is only the vertical component. No? Unlike sa yung unang orientation natin dito, magdudulot ng moment yung dalawang components. Which is, makukuha pa rin naman yung correct answer. Pero mas mahaba yung isusulat mo. Alright, so yung moment ng vertical component is CH that will cause clockwise. So force, the vertical component is FCH, sine of theta. Sine of theta. Moment arm, dalawang 1.8. So ito again, wala siyang moment. Yung other force na magdudulot ng moment is only the 17. Kasi ito wala, direct to the point siya. Ito din, yung tatlo na yan, direct to the point of moment. Wala silang moment na maidudulot. 17 lang, it will cause clockwise pa rin. 17 moment arm is 2.012. Equal to 0. Nakuha natin yung H. So that's a negative value, 2.245. So ganun yung gagawin natin. Inassume natin lahat tension. If negative yung lalabas, then it is in compression. Letter P. Letter P yung sagot. Okay? Now, yung last question dito is force on member DJ. Force on member DJ. So, maraming paraan dito to solve this one. Pwede dito natin siya i-cut by method of section. Then, tingin tayo sa taas. Tatlong forces yung unknown. Actually, we can do that. Pero sa solution ko, inuna ko munang kunin yung ating member IJ. Ito yung gagawin ko. I-cut ko muna siya in this manner. Pwede natin makat yung thrust natin kahit ipa-slant natin or ipa-curve. Kahit nga pag ganito yung ating pag-cut. Kahit yung pag ganito, pwede yan. pero maraming members yung mapuputol. Ang raming unknowns. Kung ito yung style ng pag-cut ko, i-cut ko sa ganito. Yan. So, these are the forces involved. Notice ha? Yan. You have Fij, Fgd, Fkd, and Fde. Ito yung mga internal forces. And again, I always assume away from the joint or tension. Okay? So, unknown. Apat yung unknowns. Apat yung naputol natin. Pero pag mag-moment tayo sa D, itong tatlong forces niyan is directly pointing to D. So, mawawala sila. Yung unknown na lang natin is yung Fij. Alright, so yung angle ng Fij to the horizontal is obviously theta. This is theta. Now, for this wind load naman, take note, it is perpendicular to this. Dapat yung theta natin dito. Okay? By just geometry. Okay, ngayon, moment ako sa D, analyze muna natin saan maganda ilagay yung ating component of the force on member Ij. Hindi pa muna natin makukuha agad yung force on member DJ. Kailangan ko munang kumuha ng ibang forces. Diba? Kahit mag-summation mo, kahit saan tayo mag-moment, ang raming unknown kung si DJ yung uunahin natin. So, IJ muna ako. Okay, analyze natin. Kung dito natin ilalagay yung ating component, moment about D tayo. So, Fij will cause moment. Fijx, the horizontal, will cause moment at D. So, dalawa yung magkakause ng moment. Mas maganda, okay, we can orient that one anywhere, kahit saan, basta, ano siya, on the line of action force. Pwede ko siyang i-transfer dito actually, pwede dito, or pwede rin dito sa ating point J. Ito, transfer ko siya dito sa point J. So, bale, ito yung ating horizontal and vertical component. For our loading naman, which is the wind load, so ito yung ating, dito natin siya ilalagay. Obviously, para itong vertical component, mawawala pag nag-moment tayo sa D. Yung force na mag-cause ng moment is yung horizontal component lang. So, summation of moment at D, positive clockwise. Okay, positive clockwise tayo. Una, yung horizontal component ni IJ. So, since mag-moment tayo sa D, it will cause counterclockwise. That will be negative Fij cosine of theta. Horizontal component tayo, cosine of theta. Its moment arm D is 2.7. 2.7. Next, itong horizontal component ni 8.5, that will cause clockwise moment about D. So, plus 8.5. Take note, yung theta natin andito ha. So, this must be the sine component. Kung saan si theta, yan yung i-cosine mo. Adjacent. Dito yung ating vertical, kumbaga. That's the sine component of 8.5. So, again, it will cause clockwise. So, plus 8.5 sine 2.565, the theta. Moment arm is still 2.7. Ano pa yung loads natin dito? Of course, ito. Na 14.252. Again, kung kinat natin sa dito, then tumingin tayo sa left side, disregard all of the forces on the other side. Ganun lang yan. Tanggalin mo lang lahat yung forces sa other side. So, ito, included pa yan. That 14.252 will cause clockwise about T. So, no, counterclockwise. Kaya, minus 14.252. Its moment arm is tatlong 1.8. So, wala nang force na magpapaikot about D equal to 0. Kuha natin yung Fij, negative 26.618 kilonewton. Okay, negative 26.618 kilonewton. Ngayon, 27. This is 27. Dali lang ha. 27.618. Hindi siya 26. Alright, 27.618. Ngayon, dito tayo sa DJ. Ito yung gusto natin makuha. How to solve this one? Ang gagawin ko naman, dito na ako mag-cut. I-cut ko tong tatlong members. Kasi ang hirap dito, considering this section. Ang raming unknowns. Pero madali makuha si IJ pag dito tayo nag-cut. For this DJ, i-cut ko siya dito. So, ito yung forces involved. Meron ka ng force on GK. Ito. So, take note, meron tayong IJ, meron tayong DJ. Kung mag-moment ka sa K, yung unknown is only the DJ. Diba? Yung unknown natin is yung DJ na lang. So, best option dito, moment at J. And we need this distance for the moment R. For the moment R. Okay? So, 0.9 yan kasi 2.7 minus 1.8 is 0.9. So, now, andito pa yung ating components of IJ, horizontal and vertical components. Ngayon, kung dito tayo mag-moment sa K, mas maganda, i-orient natin sila balik dito. Ganyan. Kasi kung mag-moment tayo dito, yung horizontal component, wala nang effect dyan sa K. Yung vertical na lang. No? Yan yung gagawin nyo. I-check nyo muna saan nyo i-orient si components. The summation of moment at K is 0, positive clockwise. Okay, una, yung vertical component ni IJ will cause counterclockwise about K. So, minus FGK, vertical component tayo. Yung theta is that one, the sine of theta. The moment arm is dalawang 1.8. So, times 2 times 1.8. Alright. Then you have FDJ. Ito. FDJ. So, it will cause counterclockwise, kaya minus pa rin. Moment arm is 1.8. Now, for this load, yung vertical load ni 8.5, so that will cause counterclockwise about K. So, you have 8.5 cosine. Again, nasa kanya yung angle. Cosine of theta. Its moment arm to K is 1.8. Meron pa. Itong horizontal component 8.5, it will cause clockwise moment at K. So, plus tayo. Plus, that should be sine component. And its moment arm is 0.9. Equal to 0. Take note, yung ating FGK, that's FIJ pala, sorry. This must be FIJ, hindi siya FJK. IJ. So, ganito yan. Hindi siya FJK ha. That is IJ. Yung ginamit natin. Okay? So, take note, yung FIJ natin is a negative value. Hindi natin change yung direction. So, as is the negative sign. Huwag mong tanggalin yung negative sign. Negative sign. Kasi hindi natin binago yung direction. Okay? So, substitute din yung ibang values dito. Unknown si FDJ. Just copy that one. Equal to 0. Kuha natin yung FDJ. That's 19.00 kilonewtons. So, positive yung lumabas. Assumption natin is away from the point for tension. Yung answer natin is 19.01. So, that's it for situation 21.